Operations on mixed numbers. So we're looking at mixed fractions, and we want to perform division, multiplication, addition, and subtraction on them. There's a lot of different ways that this can be done. I want to explain it in the way that I feel is the most efficient with my time in terms of like, do I convert? Do I not convert? What's the best route? I'm going to start off with this division and multiplication scenario. With division and multiplication, for me personally, my best bet, or the best bet that I can give you, and what I think is the most straightforward, is just converting. Just deal with it as converting to improper. So convert to improper. And then go from there. Convert it to an improper, and then just deal with the same set of rules that you would deal with when dealing with normal improper fractions or just normal fractions. That's what I think is the best bet. So let's go ahead and do number 1 and 2 and 3 also. There's a couple multiplications. So I'm going to convert these. So converting a mixed number to an improper fraction. So if I have 2 and a third, I want to convert that to an improper fraction. What you want to do is you want to multiply 3 times 2 and then add the numerator. So 3 times 2 is 6. 6 plus 1 is 7. So you'd have 7 over 3 is the conversion there. And then I'll go ahead and do 1 and 1, 6. So what you want to do here is you want to do 6 times 1, which is 6. 6 plus 1, which is 7. 7 over 6. So that denominator is just indicated by whatever that denominator was in the fraction portion. So 2 and 1/3 again is 3 times 2, which is 6. 6 plus 1 is 7. And then we put it over that denominator. 1 and 1, 6. 6 times 1 is 6. 6 plus 1 is 7. 7 over 6. So the conversions here are 7 over 3 divided by 7 over 6. Now it's the same set of rules that you would do with multiplying with dividing first. We're doing a division problem here with dividing fractions. So the rule for dividing fractions is you want to keep the first fraction the same, change division to multiplication, and then take the reciprocal of the second fraction. So 7 over 3 times 6 over 7. And this is really nice because now we are in a situation where we can simplify a lot of things. 7 over 7 simplifies. 7 goes into 7 once, so these just go to ones. 3 and 6 also simplify. 3 goes into 3 one time. 3 goes into 6 two times. So then I'm left with 1 times 2, which is 2. And then on bottom, 1 times 1, which is 1. And we can just write this as just 2. So once you convert, it's really just a normal problem. And number 2, 4 and 2/3 times 3 and 4/5. So converting, 4 times 3 is 12, plus 2 is 14 over 3, times 5 times 3 is 15, 15 plus 4 is 19 over 5. And unfortunately, I'm not seeing anything that can simplify at all. I don't think. Let me see. 3 times 4 is 12. 12 plus 2 is 14. Yep. Just making sure that I just did all that math. Yeah, no, nothing simplifying at all. So I'm going to do 14 times 19 across the top is 266 over 3 times 5 is 15. 266 over 15. Since we got an improper and we are dealing with mixed fractions, let's convert it back to a mixed fraction since we were already dealing with improper, or I'm sorry, we were already dealing with mixed and we converted it to improper. So now let's convert it back to mixed. Easiest way to do this is just go to a calculator, type 266 divided by 15, and then you would get 17.73 repeating. So you know this number is going to be 17. So it goes in at least 17 times, but not 18. So I want to put 17, and then I want to know, well, what is 15 times 17? 15 times 17 is 255. So that means I have to now figure out, well, if I'm at 255, because 7 times 15, and we know the denominator here is going to be 15. Remember, whenever we convert, that denominator is going to be 15 from here. Now I'm trying to figure out, well, 15 times 17 is 255. And then what do I have to add to 255 to get to 266? So I'll just do 266 minus 255, which is 11. So 17 and 11 over 15. So 17 and 11 over 15 there. Another multiplication one. 4 times 5 is 20. 20 plus 2 is 22. So 22 over 5. Times 3 times 2 is 6. 6 plus 1 is 7. 7 over 2. Now we just simplify. So with the division problem here on number 1, we had to change it to multiplication, take the reciprocal, but in these last two problems, we just have to multiply or simplify if possible. When here, luckily, we do have some simplifying that could happen. 2 goes into 2 one time, 2 goes into 22 11 times. 2 times 11 is 22. And I don't see anything else, so I have to do 11 times 7, which is 77. 5 times 1, which is 5. Make the conversion, since we were already dealing with mixed fractions and we converted to improper, so we do want to convert that back. It's not necessarily like an absolute requirement, but typically when we're dealing with mixed fractions and we convert, we want to rewrite that answer back into mixed fraction form. 77 divided by 5 is 15.4, so that means it's going to go 15 times. And then we want to do 5 times 15 to get an understanding of where we're at. We're at 75. So 5 times 15 was 75. How many more do I need to get to 77? That would be 2. So 15 and 2/5. So with multiplying and dividing mixed numbers, your best bet is to convert. With adding and subtracting, though, my recommendation here is keep as mixed. You can convert. It is 100% possible to convert and then just deal with the fraction as is. The only problem with that is sometimes the numbers get a little ridiculous. And what I mean by that is if you look at this next one, 20 and 1/6. If I convert this, so this is 20 times 6, which is 120. 120 plus 1 is 121. So I'll be dealing with the 121 over 6 minus 3 times 12 plus 1 over 3. The numbers are going to get crazy pretty quickly. In some cases, maybe they're not. Maybe it won't be too bad. But I think you'll see what I mean by leave as is, because the numbers will just keep a little bit nicer. So we have 20 minus 12. I'm going to do 20 minus 12. I'm going to just deal with the whole number parts. So 20 minus 12 is 8. So I have 8. Now I want to subtract the fraction portion. So I'm going to do 1/6 minus 1/3. This is way more manageable than dealing with 121 over 6 or anything even worse than that. And I think that's actually going to be in the realm of like not too bad. Like if you look at number 5 and 6, those could get a little bit messy with those bigger numbers. So this isn't too bad if you want to convert, but we want the LCD here of 6 because 6 goes into 6, 3 goes into 6. So I'm just going to make that LCD of 6. So that means I'm going to multiply this by 2. Get 1 over 6 minus 2 over 6. 1 minus 2 is -1. Here's the most difficult part of operations on mixed numbers, especially with addition and subtraction. So subtraction, definitely more specifically. When you get this negative fraction, because 1 minus 2 is -1, so you get -1 over 6. So my answer isn't 8 minus, or 8 and -1/6 or anything like that, or -8 and 1/6. That's not the answer. The answer is I still have to take away a 1/6 from 8. I still have to take away a 1/6 from 8. What is going to happen then? So let me rewrite this over here. I think I'm getting a little close to my camera. So 8 minus a 1/6. There's two ways of doing this. You can just make this over 6 and then multiply this by 6, change that. But I want to look at this in more of a logical sense because it's not super complicated to think about. If I'm at 8 and I'm taking away a 1/6, that means I'm now down to 7. And what I mean by like taking away a 6, let's think about it in terms of money. If I have $8, and I take away a quarter, so 4 quarters makes $1, and I take away 1 quarter from that $8, how much money do I have left? I have $7. Now I'm down to $7, right? Because I was at $8 and you just took away a quarter from me. So now I'm down to $7 and 3 quarters. 4 quarters make $1. If I took 1 quarter away, I now am down to 3. Let's do that again. If I'm at $8 and you take away 3 quarters away from me, how much money do I have now? I have still $7 because you didn't take away a full dollar. Taking away 4 quarters would be a full dollar, so I'm still at $7. But now I only have 1 quarter left. because I took away 3. See the pattern there? See the relationship there? So if I take away a sixth from 8, I am now at 7 and 5/6. If I'm going to erase all this, but if I'm at 8 and I take away 5/6, what am I at? I'm at 7 and a sixth. If I'm at 8 and I take away a third, what am I at? I'm at 7 and 2/3. So that leftover is just whatever makes up the whole. And what I mean by making up the whole is 5 plus 1 is 6. 1 plus 2 is 3. 3 plus 1 is 4. 1 plus 5 is 6. I'm just, whatever makes up that whole, that is just the leftover after you take away that amount. I got to find where I was at. I wrote a lot of extra stuff here. So hopefully that helps. Now, again, if that's still not clicking, if you're like, not really getting that, just convert then. Or I'm sorry, not convert, but just deal with it as 8 over 1 minus 1 over 6. So this becomes 6. This becomes 48. 48 minus 1 and so on. Just deal with that. Don't waste time trying to come up with the answer when you're just not sure. So just do it the long way. So you get 7 to 5/6 there. Okay, let's continue on. So number 5, 36 and a 12th minus 5 and a 4th. So I'm going to do 36 minus 5, which is 31. Then I'm going to do 1/12 minus a 4th. LCD is 12, because 12 goes into 12, 4 goes into 12. So I'm going to make this 12 by multiplying by 3. So 1 over 12 minus 3 over 12. 1 minus 3 is negative 2 over 12. Simplify. So that's going to be negative 1/6. Again, same fraction again. So we're at 31 minus a 6th. That's going to be 30 and 5/6, because I'm taking away a 6th. And I'm not going to go through the whole explanation again. But now next one we have 15 and 2/5 plus 11 and 2/3. So let's check this one out. 15 plus 11. I'm just adding those numbers together. 15 plus 11 is 26. Then I have to do 2/5 plus 2/3. So I'm going to find the LCD here of 15. Multiply this by 3. I guess I could leave this. Multiply this by 3. Multiply this by 5. 3 times 2 is 6 over 15. Plus 2 times 5 is 10 over 15. 6 plus 10 is 16 over 15. So we have 26, and then we have 16 over 15. That is an improper fraction. So let's convert that. 15 goes into 16 one time with 1 left over. And you could back this out. 15 times 1 is 15 plus 1 is 16. That would be 16 over 15. So that makes sense. So now what I have is 26 plus 1 and 1/15. Just like the same if I had 3 quarters and you gave me 2 quarters. So now I have over $1. I have 3 quarters plus $2 is $1.25. That's 6 quarters. Wait, what did I say? 3 and 2, 5 quarters. Sorry, I thought I said 3 and 3. 3 quarters and 2 quarters make 5 quarters. So I have $1 and an extra quarter. So that means I'm going to have now 27 and a 15th. Just like a quarter example, 3 quarters and 2 more quarters would give me 4 plus 1. So 4 quarters is $1 plus that extra quarter. So there is that. And like I said, you can convert to an improper for division and multiplication, keep as mixed for addition and subtraction. But then the converting at the end gets a little messy with the addition and subtraction. That typically is the more difficult side of operations on mixed numbers.